So, can you hear me? Okay, I think it's fine. Good afternoon, everyone, and welcome to the session, Next Generation of Battery Packs for Battery Electric Vehicles and Plug-in hybrid electric vehicles. My name is Martha Gialampouki, and I'm Project Advisor in CINEA, the European Climate Infrastructure and Environmental Executive Agency, and I'm here with my co-moderator, Denise Tapler from AVL. Who will moderate the Q&A session at the end. So I think, yeah, people are still coming, but we have to start, not be late. As it is well known, the European environmental policy for climate neutrality by 2050 is pushing towards rapid implementation of transport electrification. So in order to accelerate the market take-up of electric vehicles, it will be necessary to increase the density of battery packs in terms of weight and package space in order to improve driving range. Moreover, shorter charging times for battery electric vehicles through high-power charging will enable traveling longer distances. However, this imposes further challenges on cooling needs. And to add one more point here, the higher performance of battery packs raises safety issues which require more robust and flexible advanced battery management systems. So the projects of the session today are improving the performance of the electric vehicles and plug-in hybrids. Their work includes, among else, design of advanced battery packs and systems, advanced battery management systems, and the development of solutions and processes for sustainable dismantling and recycling of battery packs and their materials. We have with us 4 innovation actions projects: Liberty, MARBEL, ALBATROSS, and HELIOS. All of these projects were started 2 years ago at the beginning of 2021, and they will complete their activities in about 1.5 to 2 years. So today's presentations will highlight midterm results. Before presenting the first speaker, I have to mention that these 4 projects have also created the ALBATROSS cluster, which is very active and works in the area of sustainability, BMS, test methods and standards, as well as modeling. So I will not take more from your time, and I think it's time to welcome the first speaker, Eduardo Miguel, who will present the Liberty project. Eduardo is working at Tickerland as a researcher in the energy storage and management line. Eduardo, please, the floor is yours.
Okay, so thanks a lot, Martha, for your kind introduction. So, as Martha said, my name is Eduardo Miguel, and I will present you today the Liberty project. So for that, I will go through a brief introduction, showing you the goals that the project has, some facts and figures, the structure we follow, and some perspective through the European Commission, and following some of our key innovations, and I will also talk a little bit about the ALBATROSS cluster. Right? So Liberty stands for Lightweight Battery Systems for Extended Range that Improve Safety. So we are in the context of electric vehicle battery packs, and I will talk to you about that a little bit later on, but we have a benchmark vehicle, which could be the EQC from Mercedes-Benz, and that's also going to be the vehicle in which we are going to validate our results and integrate our battery. So we have 5 different objectives in order to improve the battery system that vehicle has. The first one would be to achieve a range of 500 kilometers, which means more than 20% of improvement. A short charging time, which is going to be under 20 minutes, something like that, which is more than half of the time. Also, we want to achieve a safe battery. No numbers in there, but we will get into details a bit later. The fourth objective will be to achieve a long battery lifetime. We are targeting 300,000 kilometers, which is an 80% of improvement. And finally, we want to build a sustainable battery pack, right? So those are our objectives. For that, we have a really nice consortium with 16 partners from several countries. You can see them in the picture. Ikerland is the coordinator, and the project started in January 2021, as Martha just mentioned, with a duration of 42 months, so we are more or less in the middle of the project. And for this specific project, we have a budget of more or less 10 million euros, right? So that being said, I want to show you a little bit our work package structure, which is strongly linked with the V-shape methodology. So those work packages are going to be targeting that methodology. First of all, we have a first work package, which is going to be dealing with the requirements of the vehicle, to follow with a battery pack design, and which is going to be work package 2, and work package 3 and 4, which are going to be the development of the battery system components, hardware components, and also the fourth one with the BMS and state estimation algorithms. And that would be the whole way down the V-shape. And to go up, we have two different work packages, a transversal one, which is going to be work package 5, in which we are designing the testing procedures and methodologies, and work package number 6, which is going to be the specific work package in which we are testing those procedures. Finally, we have a work package 7, which is going to deal with the sustainability of that battery to assure that it's going to be present in all the design phases, also as in testing phases. So now that we know our objectives, I just wanted to gather your attention regarding the framework of this project. The framework will be the Horizon 2020, and more specifically the LC-Button call. And here we can grasp most of the technical advances that we are going to be facing in this project. So we are going to be talking about advanced battery pack, especially taking attention to lightweight in the battery, crashworthiness. We are going to be talking about sustainable dismantling of the battery pack at the end of the life, flexible battery management systems in order to be adapted to different use cases, remote maintenance and troubleshooting, which is strongly linked with the digitalization that we are facing last years in Europe. We are going to be talking about high voltage systems compatible with fast charging. Also, we are going to be facing novel procedures for testing and qualification. And finally, we are going to integrate all these advances into a specific vehicle. So that leads us to our key innovations that, as I told you, are going to be integrated in the Mercedes EQC vehicle. This picture there. And so just to gather a little bit, again, the objectives we have, since are going to be extremely linked with the specific innovations we have, we want to achieve a 500-kilometer range, short charging time, safe battery pack, long lifetime battery pack, and a sustainable battery pack, right? So to start with, our battery pack is going to be a cell-to-pack approach, in which we are not going to have battery modules, right? And that's going to contribute a lot to the range and objective, since we are going to get a more energy-dense battery pack. And together with that cell-to-pack approach, we have immersion cooling-based thermal management system, in which we have a monophasic fluid, in which the cells are partially immersed. And after that, you will see that here, from the bottom of the battery pack, that the electric fluid is reflowed to some nozzles on top of the cells that are going to spray that the electric fluid, increasing the specific surface area and improving the way we cool those cells. Finally, that cooling is going to make it possible to fast charge our battery pack, as well as mitigating to some extent the thermal runaway situations. So we are going also to contribute to the safety of the battery pack. Since contributing would be not enough, we also have an active safety system in which we are going to be using that system to encapsulate a group of cells to prevent the thermal runaway propagation from that confinement of, right? And this active safety system that you can see in here, a bit more in detail, is composed of a two-phase fluid that is going to boil up in case of a thermal runaway, extracting that energy from the cells. And also we have fire retardant material in between the two rows of cells that we have in that confined group of cells that is shown in the top left of the slide. And that is going to be making it happen later in time, so that use of the active safety system is going to be less intensive, so we can size it a little bit smaller than it would be with a normal propagation. So after that, the battery management system, we were facing flexible battery management systems, and that's why we used the Fox BMS platform, which is an open source platform that's going to be allowing the use of this BMS in different case uses and different vehicles or applications. And we redesigned the slave board of the BMS with an integrated bus bar system that is going to be compatible with the electric fluid we have in the battery, and that will also allow to maximize the energy density in the battery pack in our specific case. Following with the state of X estimation algorithms, we have two main requirements in here. First one would be that we want to achieve a quick model development phase and also reduce the experimental burden. So for that, we are using neural network-based models or algorithms that brings us to the benefits of increasing the accuracy and the reliability as new data from operation is added to those algorithms. We also can improve the performance under unobserved conditions because of the same reason, because we have data from the field coming to the algorithms. And with the use of that data, we can also reduce the experimental burden that is needed at the production phase of that vehicle. So we can add later on more data to those algorithms. So finally, with our innovations, we have the battery passport concept. So with this concept, we are able to process and store real-time data from the battery into the cloud. And that will allow also us to provide advanced services, as well as enabling the transition to a second life application, which could be stationary or whichever the case it is. And finally, just a few words about the Colabat cluster. So this is a cluster composed of the 4 projects granted in the LC-BAT10 call that are here today. As Martha said, we have divided the cluster into 4 subclusters, which are going to be sustainability testing, BMS, and modeling. So stay tuned if you want to, and be ready for some events, workshops, and white papers. And that would be all. Thank you very much.
Thank you very much, Eduardo, for this very interesting presentation, and you were very well in the time. Just a reminder for the audience, please keep your questions for the dedicated Q&A session. So we'll go straight to the second project, which is MARBEL, and it will be presented by its coordinator, Eduard Piqueras-Jover. Eduard is a Research and Innovation Program Manager at EuroCAD Technology Center. Please, Eduard.
Good afternoon. All right. Okay. Good afternoon, everyone. Thank you very much for Martha for this session and CINEA and European Commission, and also thank you to you all for being here to listen what we have to tell you about our innovations in battery pack level. Okay, I will present the project MARBEL. Okay, this is going. All right, sorry.
No, it's okay.
I didn't attend that. Okay, that concerns the design, manufacturing, and assembly of a modular reusable electric vehicle battery, okay, for lightweight mobility is the title we put it. Well, you will see more or less the same contents about the expected. We want to emphasize on the expected results we are having in these projects. Project MARBEL is from the same call as the other ones for the next generation of battery packs, improving the performance of the battery pack without touching or going on innovation on the cell itself or the chemistry, but on all the rest of the battery system. The project is 3.5 years, as Martha mentioned. We are on the second year. And this project is coordinated by EURECAT Research Center in the area of Barcelona. But together with us, we have several other research centers specialized in different fields on the battery system. Also different tier ones from material development for structural parts, aluminium, for instance, NASAs, also for bus bar connections, junction box, electrical systems, etc. And automotive engineering. Iliada was presenting a nice project on simulation this morning. Battery recycler and also other SMEs. I will explain the innovations they improve. And our OEM or the car manufacturer guides our innovations in this is Group Stellantis, the research center in Torino from Fiat. Okay, the main objectives of MARBEL. MARBEL is centered in the innovation in MARBEL is focused on the 4 steps of the life cycle of a battery. Okay, not only in one of them. So from the production to the assembly, manufacturing, the use, okay, and also what happens by the end of life of this battery, and also not only in terms of second life purpose, but also in maintenance and enlarging the life of these batteries, okay? On the side of designing and conceptualizing the battery, we are working on design for circularity. We are working on a modular and lightweight battery. We are using recycled alloys. We are working with weldless modules, okay, easy to get easy for assembly to save weight, to save cost, by working with smart cell managers, communicating with the models with the BMS, so wireless communications. With these improvements, we target a 20% weight reduction of all this part of the battery that exclude the cell, okay, excluding the cell, but also an improvement of 40% of the life cycle of the battery in the design, but also in the other parts of the cycle, of the life cycle, okay, also in the use. Regarding the use, and the performance of the battery, this is some of the points that the attention to the end user of these electric vehicles cars, the reduction of the charging time and the extension of the useful battery life up will facilitate the mass acceptance, mass production and use of these kind of vehicles. But at the same time, if we gain a useful battery life, we extend the life of the battery, we reduce also their impact. Okay, so it's important also in this sense. In this part of the performance, we work with thermal management, improvement of thermal management, ultra-fast charging strategies, and advanced BMS. Well, I will go on details later on. And then one final part regarding testing, validation, and dismantling. Okay, let's move forward. You will see more details. What's the situation now? We have working these last 2 years on setting up requirements, working on the development of methodologies for this eco-design approach, working all together, all the stakeholders from the battery system, from the electrical system, structural parts, thermal management, BMS, all together to design this battery with this focus and vision. Okay, we designed the different systems, and now we find in the moment of getting things into real physics modules, prototypes, battery packs to validate at the end of the project, okay, in the proper TRL, okay. Regarding more details on the design for circularity, what we made regarding the structure of the housing, we worked with recycled aluminum alloys. We optimized it with topology optimization these profiles, and the welding solutions, because the design of this housing is, as is the whole battery, is modular. So in terms that you can use these for different applications, needing more bigger or smaller batteries. Okay, this is the vision and the way we designed this. Then from another side, the whole battery is thought in this direction of being modular, with this also including this thing of the welded connections for an easy for disassembly purposes, but also for facilitating second life applications with an easy dismantling and easy substitution of modules, for instance. Then this, again, what I mentioned, the weldless bus bar and the cell-to-cell connection, this flexible weldless bus bar facilitates this dismantling, okay, apart from the modular design. Finally, what I was mentioning previously, in the first part of the project, we designed a methodology for eco-design, okay, that we are applying for this particular purpose of the battery, okay, where we focus on the hotspots involved, and what I think is more important, we involved all the stakeholders from the all cycle stages, design, manufacturing, use, and life, and I think this makes the more powerful this method than others that maybe are based more on bibliography, etc. Okay, and with them we defined specific actions for the housing, for the connections, for the thermal management system, etc. Regarding the performance, as I said, one of the expected results is to decrease the charging time with ultra-fast charging strategies. And here today there is a colleague of the project, Carlos Apomelik from Ficosa, a company supplier of automotive, that if you have more specific questions, you have the occasion today to ask him. The charging station, junction box battery switching 400, 800 volts. This is a product designed by Ficosa. So, and then the enhanced thermal management, okay, that we're have been working with a team from ABL, with and combine it with other research centers, combining efficient cooling panels, functional aluminum profiles, that works on a mechanical, also and as a mechanical and thermal purposes, and also the introduction of aluminum foam, patented technology from Fraunhofer, to enhance this thermal management. Okay. Then finally, in the battery management system, what we made is a flexible and modular BMS that is adaptable to second life applications. Okay, so we make a BMS that is adaptable to a large variety of batteries and applications, not only for a specific car. We worked on these wireless connections with a smart cell manager, reducing wiring complexity and part of the weight, not too much, but the complexity of the connections. And then also including artificial intelligence-based expert systems that provide predictive early failure detection. Okay, this helps on the maintenance, but also helps on identifying which second life applications we can get from a battery that arrived to an end of life for the purpose of an electric vehicle. But this gives information to you what are the second life applications. The data transmission to the cloud is another innovation we are working with the proper security communication channels that permits the BMS make more complex calculations because it's in the cloud and via this communication. The expected impact is this reduction of charging time and extension of life. Okay, as I mentioned, extension of life is very important for end user, but also for reducing environmental impact of the battery. So we need 2 batteries for doing the same kilometers, better having 1. Then regarding the testing, that is where we are in the Colabat subclusters, we are leading where our partner THI, Research Center on Automotive in Ingolstadt, is leading the subcluster on testing, because we are willing to getting new standards on how we test batteries. One of the I would like to highlight innovations of our project is this battery pack test bench platform that we call it electric vehicle in the loop, that will be built in IDIADA facilities, in AP plus IDIADA facilities, that aims to be a flexible and versatile test bench, adaptable to different platforms. Okay, this eliminates the necessity of constraints of testing in a given vehicle. So you can test your battery. It's versatile to different platforms. This reduces time consumption, cost for testing, and increase also the overall system safety. We will demonstrate the complete battery pack, and also the way of this is designed. You can have also the battery and the powertrain systems in different places. You communicate, and well, something that will be very interesting when it's achieved. But this will be at the end of the project, of course. Then, regarding procedures for characterization, our partner THI is working on optimizing this end-of-line test, simplifying regular inspection, working on applying of artificial intelligence data processing to reduce the necessary tests, so anticipate results and reduce testing time consuming on battery packs, and also mechanical test procedures, not in terms of timing, but on scale, like being able to test in a smaller scale, but using to extrapolate the results on a full scale. Okay. And finally, the efficient process for dismantling. There is a partner specifically working on this that already asked for a patent in this. Yes, it's TESREC from France, a safe, efficient, and innovative process for opening pack modules and other innovations that will be worked on in the last part of the project. This methodology for eco-design was also digitally recorded by EURECAT, because I think we created a methodology involving the stakeholders. I think it's very productive for addressing all the hotspots in the battery pack, in all the life cycle, all the steps of the life cycle, from production, life, end of life. And regarding the standards, as I mentioned, we are leading the subclustering testing, standard cell testing, harmonized data for cells, for battery packs, modeling. Well, these are the different subclusters we are trying to get together, find common challenges, work on common paths for standards, and this is the main purpose, apart from joining efforts for disseminating the results of the 4 projects. Well, what's the long-term impact or impact in terms of policies or citizens? No? Let's say as European citizens, I think as I mentioned it, charging time and life of the batteries, things that will help to foster acceptance of the electric vehicle. It tackles the main critical points in consumer decision, limited vehicle autonomy and the charging time. Okay. Then we work with more sustainable and efficient electric vehicles. Okay. It's true that, well, all the business and economics and etc. It's very true, but we need to think on future. Know what happens when all these batteries finish end lives and their lives, or also what if we want to have batteries that you have to change it every very few kilometers, and then you have to produce a lot. But all these things that maybe is a more long-term thinking, but I think it's important that we take into account this when designing our future batteries. We aim to contribute in this new industrial strategy for Europe, mainly on the Circular Economy Action Plan, regulatory framework for sustainable batteries. I think it's one of the key actions for European Green Deal, apart from many others, but as I mentioned, these are the ones that we are tackling in our project. MARBEL project contributes to meet the European Union emission reduction target by 40% by 2030 by developing these more efficient batteries, electric vehicles, but at the same time design it in this circular by design approach. That would be all from my side. I don't know if I was very quick.
You were exactly at the time.
Okay,
you have like 22 seconds left.
Okay, well, then I take advantage to thank you again, because it's very good that you can come here and we can share results and discuss with the people, all the stakeholders in the sector, like we do in our eco-design approach, to do it here also. Thank you.
Thank you very much. And now that was the clock. Thank you very much. Thank you, Edward. The next project is ALBATROSS, and it will be presented by its coordinator, Irem Sapmaz. Irem is working at Yesilova Group as an R&D project executive. Irem, the floor is yours.
Many thanks. Many thanks for the informing me. And I just want to start with the words for the Turkey situation, because we are here, we are representing our country. However, we are physically okay, but not mentally, because Turkey and Syria were hit by the worst earthquake in that region for over a it's really hard to be there, because it's over than 40,000 people were affected, and we are here, but at least they are in our thoughts, and we are here for them. I just want to start with these words because we are representing them here also. Many thanks for your understanding, and many thanks for the support for the to more than 20 countries from the European region especially. Now I would like to jump into the introduction part. Many thanks for your understanding again. On behalf of ALBATROSS Consortium, I would like to welcome you on our project presentation. On behalf of the consortium, today I am going to mention some technical achievements for each work packages, especially for the battery tray developments, pack developments, and also LCA studies included. And at the beginning, I will give you a short introduction regarding the consortium overview and our overview of the project, budget, and the duration. Okay. In ALBATROSS project, the project has been already completed the first half of the year, and our total allocated budget is 10 million euros, respectively. And we are the project coordinator as a Yesilova Group. I just want to give some words regarding the Yesilova Group. We are the SME company which is located in Bursa, Turkey. And we are the tier 1 manufacturer especially for the OEMs, especially structural parts, crash management systems, or cosmetic parts which are made from the aluminum extrusion and casting subcomponents as well. And we are 21 partners from 10 countries, such a huge consortium, right? And the development is mainly focused on the battery module and packaging and the BMS, TMS development, and also not only for the design development, but also material and process development have been ongoing as well. And I think one of the most crucial part for our project is dismantling, second life usage, and the reuse and recycle part of the project. And at the same time, LCA studies is still in our focus area. Okay, what we are going to do in the scope of the ALBATROSS project. BMW i3, it's our demonstrator car, and all the technical achievements will be illustrated in the BMW i3. What we are going to do, what are our objectives? Of course, 20% weight reduction for the whole battery system, and develop some solutions, processes for the suitable dismantling, recycling, and included battery bag and the module level as well. And flexible BMS development studies. And of course, charging time reduction, approximately 25%. And improvement for the life cycle between the 15 and 20. And increase the range up to 480. It's currently between the 285 and 310 kilometer. And I think one of the most important for this objective is the very fast safety detection and presentation technology development. And also battery functionality, performance tested on the chassis dynameter. To sum up, at the end, we are going to test our ALBATROSS system on vehicle on the road test on the BMW i3. At the beginning of the work package 1, we have performed some road tests to understand the baseline functions for the BMW i3. And according to the result, we have started to make some integration studies to improve the values when we compare it to baseline state. One of the most crucial points that should be highlighted from our side, because at the beginning the main target is 20% weight reduction. Evet, yeah. What should we do? What should we do more? And then University of London, we had some challenge. To be honest, we had some challenges to reach the related target because we have specific volume and we have some novel technologies that should be implemented on the system, and it was a bit tricky. And University of Nottingham made some researches regarding the impact on the total mass on the range for the current BMW i3. The total mass around 280, and when we compare it to the total capacity increase, total capacity is 72 kilowatt hour. Even though the weight increased around 200 kilogram, the total range of the whole battery, whole vehicle is not remarkably affected due to the overall the range increases. The most important thing to increase the capacity of the battery pack as well. That's why we would like to mention this result. It's really crucial from our starting point. Now I would like to give you a brief information regarding to each work package's development. And the first one is the module development part. Normally, BMW i3 the cell selection is for the BMW i3 for the baseline vehicle is pouch cell. And we are going to use cylindrical cells for the ALBATROSS design approach. And according to what we have done until this time, we achieved higher total system kilowatt hour range, like it's around 31% increase rate. And the energy density is one of the most crucial points for the achieve the total range target. It's more than 200 watt hour per kilogram. The baseline is around 170 as well. And one of the most crucial part for us is like immersion cooling. The normally baseline car just consists of the cold plate, but we are going to implement partial immersion cooling system for the as a cooling method. And the whole cell terminals and weldings and bus bars are cooled effectively. And let's continue with the module BMS developments. And from now on, we have completed the current status of the battery management system is built on the master-slave approach, which gives us an effectively and flexible approach for the further development as well. And also early warning systems can be implemented for the current state, and they are okay. How we can say, the result is not official, but the current analysis for the charging time reduction is we are going to reduce 20 minutes charging time according to the current development for the BMS architecture as well. And immersion cooling is implemented and connected to BMS effectively. because a design of the interface between the modules and the immersion cooling were improved to achieve the ultra-fast charging approach target as well. According to the tray design of the current system, it's totally different from the baseline tray design of the BMW i3. In this scope of the project, we are going to implement hybrid material usage in the battery tray. Top cover and side beam will be manufactured by composite materials. The top cover will be manufactured by the non-woven recycled carbon fiber polyamide matrix composite. And the side beam also will be continuous carbon fiber composite as well. And we are going to illustrate extrusions, profiles, and the casting nodes as well. The welding operation is tricky for the both casting and extrusions. Therefore, there will be 3 different welding technique will be illustrated in the battery tray system. And the castings will be welded by laser welding. Bottom plates will be to achieve the sealing properties. Friction stir welding will be used. And the whole aluminum interactions will be welded by CMT technique as well. Not only for the BMW i3, but also the whole design approach will be illustrated 2 different types of the application. One of them is light commercial vehicle. Ford Otosan is our partner, and they will be adapted to hold the battery system design into their vehicle. And also not only for Ford Otosan, but also Daimler, Mercedes-Benz, Truck Turkey will be illustrate the modular concept design of the ALBATROSS battery tray system in their vehicle as well. But their approaches will be totally different. Ford Otosan will investigate the cooling system on their vehicles, and Daimler will test the whole mechanical shock test, road test as a virtually, and they will make some comparison studies. Is it feasible to manufacture it in their facility in real life or not? And this is the dismantling part. And they have some advanced AI techniques that can detect the screws on the battery pack dismantling. It works effectively. At the end of the project, the battery cell of the ALBATROSS will be dismantled with the help of this approach as well. And also, this is one of the most crucial developments from our side, because recycled anode and cathode material for the as a black mass, NTNU performed some leaching operation with the sulfuric acid, and they got nickel, manganese, and cobalt from the mass as a precursor, and it's a really good point to get the remained amount of the elements are quite applicable and okay. It's a really good progress for this part as well. And also we have developed some algorithms to detect the state of health, state of functions of the battery systems. It will be a synthetic test that can lead us to understand cells can be used for the secondary life or not. And also there are some cloud systems and for the algorithms that can it's a agnostic cloud that provides you can put your or deploy or install all the inputs to the system, and you can understand, you can follow up wherever you are, and the web server has been created to track of the activities on the web portal as well. And also, LCA studies are still ongoing for both the technical part and also social impact part, and they have created some portals that provide the input the temperature and analyze the battery cell characteristics and charging and discharging phases. And it will be a great opportunity to create the battery cell design, battery pack specification, and simulation before the, how can we say, physical demonstration as well. Okay, what's our mid to long-term impact? Okay, just I got it. Okay, we are going to understand the immersion cooling is feasible or not, and we are going to illustrate the challenges as well. And also, we are going to validate all the developments on the road test. And also, we are going to understand the reduction of the environmental impacts of the electronic waste. And also, we can understand and we can get a chance to a semi-automation process for the battery dismantling part. And also, we can have a chance to monitor the battery packs and their performance as well at the same time. And BMS developments also, how can we say, meets the core challenges and the safety from the safety approach, flexibility and longer use life as well. And the algorithms are also quite okay for the detection of the operation during the modules as well. Okay, I think it's already completed from my side. Please do not hesitate to contact me if you have further questions, especially for the technical part. I can raise them and I can give you a detailed information regarding what you need for the further development. Many thanks for your understanding.
Thank you very much, Irem. We can proceed to the last but not least project for this session. It's HELIOS, and it will be presented by its coordinator, Corneliu Barbu, who is an associated professor at Aarhus University in the Electrical Computer Engineering Department.
Okay, great. Thanks, Martha. So just to follow up what Irem said at the beginning, we have a few of our colleagues are in Turkey, and that's a difficult time. Luckily, none of our close colleagues have been impacted by the earthquake, but we know that this is a tough situation. We're going to have a few links on our website and social media and things like that to make donations to some of the Turkish organizations. Those are directly managed by our Turkish colleagues. So, yeah, we work as a team, well, especially in hard times, right? All right, so on HELIOS, so this is our project. We started about 2 years ago. It's innovation action. Martha is our coordinator. Yeah, I put this long number there just to show that accounting can be a real science. So this is a description of the project. Basically, we're looking into developing a smart modular scalable battery pack for a range of vehicles with improved performance and all that. So what does this actually mean? Basically, smart, we're looking at different digitalization techniques, building a digital twin to basically evaluate the performance of the battery pack in use and be able to say a little bit more about their potential for second life. On the modular side, we're looking at modules not because we put the cells in a module, but the different modules are going to have different functionalities, and I'm going to talk a little bit about this as well. We're looking at a scalable concept. So this is not for just one car. It's meant to be designed for a range of cars of any size, and also for an electric bus. So the way we look at the problem is basically on a bigger scale, and used, of course, in urban mobility, maybe some other scenarios as well. I have here a list of objectives. So basically, yeah, we look at a number of concepts regarding the circularity. We want to look at strengthening the supply chain a little bit more. We're working with car manufacturers. We're developing standards for BMS communication, among other things. and yeah, generate IP and those kind of things. We want to increase the energy density and the volumetric power density of the pack. Basically, the key concept here is that we're looking at hybridizing a battery pack. So as opposed to just using one type of cell for the whole pack, we look at a dual chemistry, two different types of cells, one high power, one high energy, and basically combine them to achieve some of these objectives. Why is this interesting? Well, I mentioned the modularization before. Potentially using two different types of cells, then maybe the pack can be customized or reconfigured to address different driving styles. So, for example, if you have a more urban driving style, then maybe you want a little bit more on the high power end, and maybe not interested that much on range. Potentially, if you are more of a commuter style, then maybe you want a little bit more on high energy and less on high power. What do you do if you change? If you live in the city and go on vacation, well, potentially you can swap some of these high power modules with high energy modules. So there are some advantages to this, mostly around customization of the battery packs, depending on the driving style. Some other technical issues as well, increasing life, charging time as well. So we're looking at 10C cells, even more than that, so potentially charging time could be in six minutes or less. Yeah, and looking at high power charges, of course, increasing the number of cycles, those kind of things. And of course, the impacts afterwards are aligned to this, basically improving the performance, improving the supply chain, of course, all EU-based, those kind of things. We have a number of partners, so we are about 18 partners. It's a pretty big project. There are over 80 people contributing in one way or another to the project over 100 many years, so quite a bit of effort. We are coordinating from Marcus University, and we're also looking at some technical issues related to BMS, modeling, control of the thermal management system, digital twin, those kind of things. Karlsruhe is doing a lot of testing on the battery cells. Izmir is looking into the thermal management system. Aalto has a pretty good team on LCA, LCC analysis. They're looking at evaluating cells and some of the technologies as well. IREC has a pretty good contribution on LCA analysis as well. RDUP is in charge mostly with the fleet management system, quite a bit of good work done there. Envision is developing the IoT. Vestel is looking on charging and second life applications. Vitesco has a very good platform that we use for the BMS development and some other new sensors that they are looking into. INEO is doing a lot of work on FMEA analysis for the cells, but also for the technologies that we're developing as well. Bozankaya is an e-bus manufacturer, so they're going to look at testing the battery pack in traffic, hopefully towards the summer of next year. UPC is developing the power electronics, a lot of testing done for the battery cells, again, at ZSW and DTI. University of Sofia is looking more into the module and pack design, the hardware part of it. Tupitak has done very nice work on the cell selection and the architecture of the battery pack. ECI is looking into bus bar and some of these issues, and then the dissemination done by CINEA. This gives you an overview of some of the technologies. As I was saying from the top, we're looking into some of these digitalization techniques, digital twin models, those kind of things. We have an IoT platform. Yeah, the fleet management system, BMS with all the different models that have to be developed there. You see on the left-hand side a little bit more on the battery testing and modeling done at KIT, ZSW, and DTI. LCA, LCC, those are very, very important things that they were looking into. So a number of technologies I have here, and probably the slides are going to be distributed. I have here a list of technologies. I think to keep in mind is that, we started pretty low TRL. We have to ramp it up towards TRL 6, 7 towards the end of next year. The way we looked at it was basically going to the component development, and this is what we did in the first 2 years. I'm going to have a little bit more on the next slide, and then move towards modular integration, pack integration, testing, and those kind of things. So basically, looking at this a little bit, the schedule is that we're going to finish the cell testing pretty much in the next few months. Component design is going to be done in Q1. It's going to finish in Q1 this year. So basically, in a couple of months, then we're going to do component testing and validation in Q2. Component manufacturing is going to be done in Q3, and the assemblies of the components in modules in Q4, and testing the modules. We're going to assemble the modules in the pack beginning of next year, and pack integration in the vehicles middle of next year. So maybe just to say a few more words about some of the accomplishments. This is the flow chart of the different work packages. Probably not too many surprises there. We spent quite a bit of time in the first year to develop the requirements for the cells, power electronics, battery management system, the testing, the integration of the cells in the modules, module testing, pack testing. We looked at standards and all that. So I think this was a pretty thorough analysis, and then we did quite a bit of work. You're going to see in the next few slides in work package 2, 3, 4, 5, and 6. We haven't started 7 yet. This is going to start probably towards the middle of this year and continue until the end of the project, end of next year. And work package 8 we just started. So we did quite a bit of analysis on the LCA, LCC, mostly on the cells so far. We have included, in terms of material selection and things like that, LCC and LCA analysis for the technologies that we're developing, the thermal management system, those kind of things. We spent actually quite a bit of time defining the hybrid architecture. We evaluated, well, first of all, for the cell selection, we discussed with some 30-plus cell suppliers worldwide. I can tell you how exciting that discussion was. We've been able to select a few. We received the cells. Those are in testing. In terms of the hybrid architecture, we actually did a pretty thorough analysis on what could be the KPIs to basically decide how we select the cells and how do we assemble the cells in the modules. Impact on the power electronics and BMS and things like that. So basically, we came up with some 54 KPIs that we ranked. We looked at different concepts. We used some design for Six Sigma approach. So this was a pretty thorough analysis on what is an optimal hybrid architecture for a range of cars to achieve the metrics that we set ourselves to achieve. The point of this is that we selected some cells. If some other cells come on the market, then we can simply repeat the process and come up with an optimal architecture. And then we started designing some of the modules as well. We have a pretty solid work package on thermal management system. So of course, because we have two different type of chemistries, there are some questions there as to what is the optimal architecture for it. Do we need to have two thermal management systems? Do we have to have one? We did quite a bit of modeling on this, and now we're at the part where we selected. So again, we applied this design for Six Sigma to select what is an optimal architecture for the thermal management system for our hybrid pack. And now we're in the middle of actually designing this system, testing it, and getting it ready to integrate in the modules. On the data, cell testing, data collection, this is a pretty thorough task. Again, we are testing the cells that we have received, the two different type of cells in 3 different locations, 2 in Germany, 1 in Denmark. And then we did quite a bit of work on model development as well. So this is supposed to end pretty much in a few months, and then use these models for control, including them in the battery management system, digital twin, those kind of things. We have another good segment on power electronics and BMS. Essentially, the strategy here is to use the BMS that Vitesco has and enhance its functionality for the hybrid battery pack. We're looking at wireless technologies as well. We're looking at a number of different sensors. hydrogen, CO2, humidity, temperature, those kind of things. So we're going to have a multi-sensing unit associated with this, and of course with all the changes required for the BMS to be able to communicate with this. So we're in the process of developing the BMS for a hybrid pack as well. We have, let's say, a digital package where we look at different IoT issues, digital twin, a fleet management system. So we have here, listed some of the results that we have already achieved in the past 2 years. But of course, we have a little bit more work to do before we integrate everything in the modules. And I put here a picture of our happy General Assembly in the summer last year, when we were able to finally meet together, half in person in Barcelona at Polytechnic University there, and half of us online, so about 50 people. That was pretty good. But it does make a difference meeting in person as well, as opposed to just online. So that's what I had. Thank you.
Thank you very much, Corneliu. So I have to say something here. So I know very well all these 4 projects. I have to say that these 4 projects are very hard-working projects and people behind these projects. And having these projects working in batteries and electric vehicles, I think we still have hope for a greener planet and a better future. So thank you very much for all the hard work you have done during these first 2 years. So now shoot them with questions. So I will pass now the floor to my co-moderator, Denise Tapler, who will moderate the Q&A session.
So thanks, Martha. I also want to thank the speakers again for giving us an overview how next generation of battery packs could look like. So I want to start now the question and answer part. And since this session is recorded for people online, and since this room is quite big, please use the microphone Lucy is passing around. And I also want to kindly ask you that when you ask a question, please state your name and your affiliation and to which project the question is addressed to. So now the floor is open. I'm looking forward to your questions.
Hello, I'm Carlos Amailec from Ficosa. And now that you are here and you worked in projects without modifying the cell, it would be good if maybe you comment the status of the cell industry that you may know because you had to purchase them.
So who wants to start, or should we go in the direction you presented? Or?
I think all of us, since as mentioned, we don't work on cells, but we need them as a basic element on our batteries. We, on our exploration, we find ourselves very dependent from foreign countries, mainly China, and that's supported some well, doesn't facilitate things if you have things more close, no? But yeah, that would be my experience. I found a big dependence on foreign countries, especially in China.
Does somebody else wants to?
So probably depends what we mean by status, right? So in terms of technical performance, I mean, I think that's, known. I mean, manufacturers are publishing the data as much as, we have had, kind of uphill battle to get the cells, right? And, 90% of the companies that we talked to were in China, of course. I think that's one of the things that why we find Helios to be actually quite interesting, because what we're trying to do is basically, split the chemistry and not necessarily wait until somebody has a holy grail cell. So in other words, if we split the chemistry and look into high power, high energy separately, then we don't need to have a cell that magically hits 2 birds with 1 stone. both charging time and the range, right? And maybe separate the problem and let's say not rely that much on chemistry, but rely on everything else except that. Power electronics and digitalization and all these things, right? So maybe, this could be a strategy to, avoid trying to play catch up, and use chemistries that maybe are not that complex, but increase the complexity. I mean, there's going to be an increase in complexity somewhere, right? But increase the complexity on the other side. But yeah, that has been difficult, and there were some other issues as well regarding the size of the project. I mean, so I don't know if that answers anything.
Yeah, actually, in the line of what you were commenting about, Cornelio, it's also true that working on the adaptability of our systems, it's also a key point in being able to free a little bit from that dependency that we have, which is self-supply, because we never know when it's going to be cutted, or if it is going to be cutted. So having adaptable systems is also a good, well, there's no good solution for that, but the best we can do.
Maybe I can add some comments in this regard. During the cell selection term, it was much trickier than we thought because it was really hard to manage the objectives and the current status, but supplying part was also took longer than we expected. 2 months delay. It can be acceptable, but we had to stop some technical progress because of the delay of the supplying the cells before the running the tests also, cell characterization tests. But the 2 months delay can be highlighted for this time.
Okay, thank you. Are there any other questions? Lucy?
Yeah, this is Anwar from Stray, Sweden. I have a follow-up questions about the cell selection and cell sourcing. I know it's difficult, but it will be nice if any of this project coordinator can give us some information where we can source the commercially available quality cells. I know that probably you source it mostly from China, my understanding. All these new projects now requires to source the cells from Europe as a first choice, but I found it is very difficult to find actually commercially available cells that produced in Europe with the specification that we need to work on the project. So any information that you can mention, okay, this company can provide the good quality cells in Europe, would be very appreciated. Thank you.
You want to answer? I know it's hard to answer. You can answer.
Yeah, actually, I don't have honestly, Eagerline is not the partner in charge of selecting the cells, but all in all, I don't think there is a very good answer to that because the situation is changing really a lot day to day, so sorry, no insight on that.
I'm sorry. I think it's tricky to give an answer here, so.
We're just starting another project, and we are self-sourcing, so I'm super stressed right now.
Yeah, I understand this. I think most of the companies have the same problems at the moment. Okay, I think there was a question, you see? So in the third row.
Thank you. Çağla from Syro Energy, Turkey. I have a couple of questions, not so that difficult, no worries. So for the Liberty project that you said you are doing real-time battery data storage for battery passport. So did you consider the data frequencies and data storage capacities for scale-up to monitor all the fleets? This is my first question. Maybe I can ask the second, then I will give the microphone. My second question to all of these projects. So you said that you developed some AI-driven fault detection or BMS SOX algorithms. So are these models or methodologies are available on your website or any publications? Thank you.
So towards the liberty-related question, yes, we have considered, and we are actually working on that right now. And it's one of the hot topics, which is the rate that we actually need. That's going to depend a lot on the service you want to provide on the cloud, on the type of algorithms you are running, whether it is on the cloud or on the BMS or even in a third device. And it's not an easy question, and it's going to be dependent on the system itself that you are using. So there may be some rule of thumbs, but it's going to depend quite a lot on the system itself, the specific one. Other than that, I cannot actually disclose anything else right now, but if you want, just you can contact me and we could get into more details. Thank you.
Regarding MARBEL and the application of artificial intelligence to predict degradation of cells, and also for future Second Life applications, this is done by a research group in University of Athens that it's called ICCS, and I think they already published something. And anyway, if you keep in touch with us, or I can do more research on that and give you the links.
So for Helios, I mean, we're looking at different, well, evaluating different faults and failures and things like that. We don't put that much emphasis on the cells, simply because there's not a technology that we develop. And of course, you know, characterizing somebody else's product, I mean, it's interesting, but I think we should focus on our own stuff. So basically, we look into, you know, understanding failure modes and all these things regarding technologies that we are developing. And for that, you know, because some of the technologies are new, we have to crash them. And so we are testing to failure. But in doing that for a prototype, probably we're not going to have enough data to actually apply any of these AIs and, you know, things like that. So the bottom line is that we do a careful FME analysis for all technologies that we're developing, including modeling, which is an interesting question in itself, but not necessarily applying AI techniques right now.
For the ALBATROSS project, the tests are still ongoing and the test progress has not completed yet, but it will be completed end of this year, and probably they will make some publication to to clarify the progress development for especially for the artificial intelligence part or the sensoring and the early detection part, and probably they will make some publication at the end of this year.
Okay, thank you. I think there was a question. Yes, perfect.
Emma Briec from Green Innovation. From this session, I was expecting more about battery packaging integration, and all the packaging I saw, maybe I missed some, are cell to pack or cell to module. But the next generation, and for which most of the OEMs are working, is cell to chassis or cell to body, which is much more optimized. So my question is for the project leader and for the commission. Is there any project working on that? Because the competition is working on it.
Martha, do you want to say
yeah.
something from there?
So, as far as I know, I don't recall a project working on pack to chassis. The most of them are indeed pack to cell, pack to module, cell to module, yeah.
I think, yeah, yes, I think.
So maybe I can say a few words from Helios standpoint. This doesn't really apply because so it's a hybrid pack, so we use two different type of cells, right? And we want to be able to actually exchange them, right? So we're doing cell to module, module to maybe semi-pack. We haven't found a good name for that. And then to pack. So that, you know, if we have a string of modules that are only high power, we want to be able to replace that with high energy potentially, right? And achieve different functionality of the whole pack. So I mean, I think those are interesting concepts, at least for Helios. They may not necessarily be applicable.
From the Albatros side, especially at the beginning of the project, we were considering plenty of options for the module and cell developments, but I think it's directly related to your demonstrator car, and because there are some boundary conditions for the demonstrator car, and sometimes it cannot be applicable for the new approaches on the your current demonstrator car. For us, especially BMW i3, it's 2019. We couldn't have a chance to demonstrate the new approaches for the current status of the BMW i3.
So maybe liberty perspective. I mean, I totally agree that it's could potentially be the next generation. That's for sure. But we also have to take into account that in this type of projects, we're facing many different innovations in many different aspects. And if we are very, very ambitious in one of them, I mean, has to live with the other ones, and we cannot tackle everything together. So this still would be really nice, but we have to make live all those innovations together.
What I would say, I also get involved on terms of new materials, multi-materials, etc., and getting structural parts that make the both functions of housing and a structural part of the car, etc. This is one approach, but in this call, where we are looking for modularity, versatility among different platforms, etc., the approach I think is different. The advantage is it's different. It's on building, designing something versatile that can be used in several applications, more than one specific platform.
So I think the question was answered. If I think they stated from their project, so maybe if you want to have a discussion, you can do it during the coffee break, if it's okay for you, or is it just a follow-up question? Okay, so please discuss in the coffee break. Okay. I think, sorry, in the second row, I think you're waiting for a long time.
Johan Blondel, DGRTD. We've heard a few different approaches, and I understand that for the selection of your demonstrators, you were restricted by commercial availability of cells. But could you comment on the impact of the cell geometry or the cell type? So prismatic versus cylindrical, different cell diameters, how this impacts the cooling concepts, for instance, and the structural integrity of the concepts that you have developed. Thank you.
So maybe you want to start in the direction you presented?
So, well, regarding the effect that we have in there, I mean, we have a baseline vehicle that we have to adapt the battery pack to. So we are facing quite a lot of restrictions in that sense, because we have already a defined space for design, and already, I don't know if it's the case for all the projects, but we have a frame for the battery pack. So in that sense, we have to adapt the development we do to that space, rather than would be
the normal process to adapt it to the whole vehicle and to get the most advantage of the whole space we have in there. So that's first thing, could be more optimized. And the cell geometry could be optimized, but it's not only that. I mean, you have the thermal management system, you have the electrical system, you have a lot of systems together. That makes not a straightforward task to select the geometry itself, and you have to take into account the whole system from my point of view. It's not just about selecting the geometry for the specific energy. That could be an option and could be a starting point, but after that you have to take into account the whole system together.
Well, I will comment. Well, as coordinator, as you know, we don't know all the details, and this one I don't know very much. But I would say that depending on the geometry, if you intend to have a battery pack more modular, easy disassembly, etc., certain geometries could help on more design for disassembly and things like this. Example of very difficult to disassembly is there would be a Honey panel of cylindrical cells, for instance. And easy for disassembly would be our case, our design. But yeah, that would be what I can say.
I think it can be directly related to space that you have first, because, and secondly, what's your target? You know, if you want to get rid of extra part for the cooling operation, you have to select your cell according to the, for example, immersion cooling implementation, and you directly select the cylindrical cells to implement the immersion cooling for the cooling, to get rid of extra cold plate or cooling pipes, whatever it needs. And that's what we had faced a really difficult situation during the cell selection term, because cylindrical cells, yeah, we got higher energy density. It's quite okay, and we can catch our target. It's okay, but the weight and the number of cells increased, and it's one of the most remarkable part for that. And I think the most important thing, what you get from what is your results, what's your expectation, and the cell selection is directly related to your expectations, I think.
Yeah, so for Helios, I mentioned earlier that for the pack architecture, we evaluated some KPIs. Cell geometry was one of them. We had some 53 others, right? So I mean that's certainly important. After we selected the cell geometry and the type of cell, we were actually quite fortunate to work pretty close with the cell suppliers in terms of understanding how to use the cells, swelling, foam, all these things. So a close relationship with the cell supplier actually helped. But of course, the rest of the systems are customized, and we're using both pouch and the prismatic. And so everything else afterwards is customized for the type of cell.
Okay, thank you. I've seen a microphone somewhere.
Okay. Horst Flügel from AVL. My question is maybe related to that, but maybe more to the future. So, because the current experience is, you showed very well what is possible here. But if we look into more into future, more years, whatever, 5, 10 years, maybe also taking into consideration that solid state batteries could arise. So what would be your expectation? I think it was also a valuable comment, what is about cell to chassis. So, I mean, these are long-term consideration. From your experience that you have now, are there any predictions that you could give there? Or, I mean, just considerations?
So maybe I can throw some thoughts here, right? So I personally don't think it's going to be a silver bullet. So we're going to have probably several technologies on the market, maybe not a lot, but more than one. And also depending what is optimized for different use cases, those kind of things. I mentioned hybridization quite a bit here. Essentially, where we saw, benefit in using high power, high energy cells is, let's say, for drive cycles which are similar to a bus, that requires a lot of start and stop cycles. And so the more aggressive drive cycle, part of the drive cycle can be taken by high power cells, and then the more cruising drive cycle can be taken by high energy. So probably, it's going to depend on the type of customer in some sense, whether it's going to be hybrid or one cell or solid state, right? I think we also have to account for the fact that by the time the solid state is going to reach a maturity level, then what we have now is going to be even more mature. So potentially, there could be customers which have, are a bit risk averse and just stick with the technology that they know. So I think it's going to be, we're going to have options, which is a good thing, right? So.
Does somebody else want to say something about the future?
Hello, this is Frédéric Chausson from Strat Anticipation. I have a question regarding the, when you talk about wireless communication in the battery, that would be, if you could say a few words on that, that would be question number one. Question number two, also for you, you were talking about the pack casing that was not welded. So you use stamping or question?
I think I expressed myself not correctly in that in terms of the battery housing, we create profiles that are extruded profiles that you can extrude more long, less long, cut, and then weld, but there is weld, yeah.
So there is welding?
Yeah, there is welding. What there is no welding is in the bus bar connections that are weldless and are being investigated by an Italian company, Agrati, working on that. and the first, and the other question, sorry?
The first question was
the smart cell
regarding the
manager.
wireless.
Yeah, right. There is one part of the communication between the module sensors to the BMS, BMS Lab and BMS, that is made wireless inside the battery. So there is a smart cell managers called ISCM, one components that lecture data and send it via wireless to the BMS. And I am looking to Carlos because he is in Ficosa. He's in the work package that are working on that, just in case I say something incorrect. And then you avoid the wires, the complexity of the wires. And this is made by an engineering company in the region of Barcelona, well, more in Girona, that it's called OTC Engineering. They were this smart cell manager. Yeah. Correct, Carla?
Maybe a follow-up question from my side regarding the wireless communication. What's about the security, cyber security and so on? Because it's a large topic and leads to discussion.
Well, the communication is inside the battery. What I know is that the data, I think, Carlos, do you want to? I think we are communicating to the cloud, and then there are some gateway and security there.
Well, we have to separate it between two levels. I'm involved in MARBEL, so that's why I can answer. Not some kind of strange guru. Well, internally in the BMS, the objective is to substitute the communication connections between the cell manager and the BMS. This is for two reasons. First of all, to avoid errors while plugging the cables, and the second of them, a part of cost, and the second is to ease automation of the assembly of the modules. Because once you get rid of these connections that somebody has to go and do it, it's easier to automate.
And regarding security?
Yeah. And about cyber security, it depends on the layers you add. in the end, the communications are close field communications. So it depends on the on the load you pay in the communication. Nothing.
All right. Thank you.
Thank you.
And I had a question, by the way.
That's perfect.
Well, I will present myself once again, Carlos Oelek, Fricosa, for the people who is in LinkedIn watching this. I have the impression, and I say that I've been involved in this project, that somehow the automotive industry is going faster than these European projects. I see that some technologies that are shown here are already in the market. What are your thoughts that could be improved in these calls? Because in my opinion, this is already late, and we are in a very big competition with a worldwide market.
Yeah, maybe one of the solutions for that could be to restrict more the objectives and focus more on specific topics, because if we have to tackle more advances in the same project, the resources are just not enough, and that could be a solution to focus. But I don't know, Martha, you may know more about that than me. But from a project perspective, that could be an option.
So for Helios, you know, we have a few industrial partners, and they are developing the technology at the pace that they are developing the technology. And so I think, you know, in terms of go-to-market strategy, they have a plan there. So I think it's timely. With respect to the hybridization concept in general, as far as I know, there is only one company in US. It's called One. That's looking at dual chemistry batteries. Okay, so there are not too many. So you know one in China, I know one in US, and we all know one in Europe.
I also think Mabel wanted to say something before.
No, it's a difficult question, because it's true that the timings of all these programs, no, it's the timing it is, okay, and we need to evaluate proposals, etc. But sometimes I think it's how to take the most from the opportunity on being working with public fundings for innovate and address challenges of the industry. So it's true. Maybe for me it's well, it's one on architecture or designing of programs and maybe timing, etc. That could be, but also once we get the projects, we need to work very close with industry and try to maybe readdress challenges while developing our project and getting into the state of the moment. So for this reason, it's important to work together with research, with industry. Yeah.
Maybe I can add some comments in this regard again. My answers are totally same, but we at the beginning of the project, it was at the beginning of 2020, and the proposal term was 1.5 years ago, and according to the current development, you selected the best option for the implementation for the proposals, you know, and then it's when 2 years later, and your implementation or technical achievements cannot be applicable for the infrastructure of this car, you know, and that can be tricky at this stage. Maybe you can change your demonstrator car, but it can be a bit late to change the demonstrator and then refine the proposal, and then that's why the most important thing, yes, you're totally right. At the beginning, we thought these things, but we are also facing same problems because the infrastructure of the car is not applicable for our improvement, and we have to make some minor revisions on the car as well.
Okay, so one question in the front.
Hello, this is Frédéric Chausson again from Strat Anticipation. I'm not going to ask a question. I'm just going to say that since yesterday and today, I saw very positive things. So yes, you might be late, but the project were starting 3 years ago, or 2 years ago. And let's not forget 2 years ago, where were we? The battery pack has changed so much within such a short amount of time that, yes, of course, maybe some projects are late, but I think what's important for Europe is that all the work you do is so useful for us to have people with the knowledge you are accumulating because we are late. And to catch up, what you're doing is great. So thank you, Europe.
Thanks for these nice words. I think there was a question in the, yeah, I didn't see. Thanks.
I try not to ask any technical question, but to encourage the panel that you set up this afternoon, compliment. Two people were referring to artificial intelligence, and you reminded me when I was younger, there was a professor of mine at MIT Media Lab. He set up a very nice experiment to measure the intelligence of collective intelligence of a group of people. He started with 100% of men, and then he eliminated one man and added one woman, and then another man, and then another woman. When increasing the number of women, the collective intelligence of the group was increasing and increasing and increasing. In the picture that we saw before, there was a woman at the end, hidden by a group of men. I would suspect that the collective intelligence test was not so high, my just impression. So I would encourage, for sure, to increase this share of participation of women, to have different point of views. We really need different point of view. So just encouraging this aspect. For the rest, I would say, if you allow me one short technical consideration, cell to pack now is, cell to chassis is the norm today. Boy, Tesla. And why nobody's talking about what Tesla is doing in this monoblock pack, having no access to the cell? Can you comment on this? Because BYD is also doing the same. Rivian is doing the same. We on bike are doing the same. No way to disassemble the pack. No sense, according to me. And I agree 100%. What is your opinion on this approach? Cell to chassis directly, monoblock, nobody can touch it anymore for 12 years. What is your opinion?
Okay, who wants to start? So we again at the beginning.
Yeah, I think that it's important to think on what happens when things arrive at the end of life, no matter it's 20, 30, 50 years. And also these concerns on the supply of materials, the resilience of the union in this term. And it's again, I think, yes, I think there is sometimes conflict of short, mid and long-term visions, and I think we need to at least a bit care on what happens in 30 years, despite, yeah, now it seems that it's not relevant. But I agree, it's a balance, and I would not say this is the norm and this is discarded. I think we need to think a bit on both things, on what's competitive, but also on what on the long-term vision.
So I'm just going to make the same comment as before on Helios, right? That this doesn't, I mean, we're looking at different things, right? And this kind of, modularization, high power, high energy, has various advantages, right? Customization, potentially the cells can be used for second life for different applications, high energy, high power also in second life, ancillary services and those kind of things. So I mean, at least for Helios, it's just simply a different approach.
Any other comments? Okay. Are there any other questions? Okay, good. Then maybe one question from my side. Since it is in the title of most of the project, and we have seen during the presentation of ALBATROSS that the impact of battery mass on the range and the capacity has the greatest influence. And when we look at Tesla, they're using steel. So my question, is lightweight really a future option? For everybody, I think, since
I mean, I think it's an option, but it's really dependent on the design, and not only in the design, in the fabrication of the packs. So I would say it's an option, but it's an option among any others that could make a hole in the manufacturing of a car. I mean, we cannot say that because of Tesla's using steel, steel is the only trend or even the best. Probably is the best for them, but might not be the answer for everyone. I know.
We are also aluminum manufacturer especially for the subcomponents for the OEMs. Steel is an option. However, we are defending the sustainability of aluminum for this case. Yes, we are if you are using primary aluminum alloy, that can be really high, but we have also some metal quality improvements for the secondary alloys to use in the automotive applications to achieve higher mechanical enhancement for the mechanical requirements. Like it's comparison of the steel and aluminum, it's not applicable because steel is much higher, but however, it can be used if you are using secondary alloy, it can be compatible for the steel versus aluminum, because in aluminum, for example, extrusion, the investments are lower and the application area is wider. For the steel, the tools and the stamping tools especially, the investment rate is totally high and it's really hard, and the scrap rates can be discussed internally because aluminum has lower scrap ratio when it compared to the steel option also.
Thanks. Is there any question from the audience? Any further questions? Okay. So I have another question. It's for Liberty. Sorry, you're sitting next to me, so I'm facing most of the questions for you. So the objective of Liberty is to upgrade battery performance, safety, and lifetime. But I think also cost reduction is one very important parameter. So how can costs be reduced when using innovations like new materials and especially immersion cooling, which is not really, how should I say, state of the art at the moment?
So, I mean, I'm not the biggest expert on that area, but one of the ways for me would be to reduce the amount of components. That would be one that help in weight and in cost. And basically, that's probably the most influencing one. Reducing amount of materials, and the cell-to-pack approach helps in that sense also.
Thank you.
I think my microphone is not working. Maybe I should stop the question and answer. Or we shall? No, I think. No, it's working. Okay. Any further questions? Good. Maybe one further question to MARBEL.
No, it's not that hard question. Maybe I missed it. How do you want to analyze and determine the suitability of the battery pack for second application, second use?
The BMS, wait, sorry. Yeah, the flexible advanced BMS that we made, it will get information on what is the state of health of the battery, and then be able to propose second life application. So this information would be available to then get direct application on second use applications. Yeah. More or less.
Good, thank you. Any follow-up question? No. I think there were that much questions. Maybe one question to, not to Liberty, because you mentioned it in your presentation. It's about the battery passport. I think this is also one very important thing that will, when we talk about future. So how is this addressed in MARBEL, ALBATROSS, and HELIOS, the battery passport, and the connection? Yeah, and the connection to the data, data sharing.
Well, in this specific, in MARBEL, sincerely, we don't address battery passport for the components. Okay, what we made is to this anticipation on the degradation of the modules. Well, anticipate when this will end life of modules, then be easily disassembly to other purposes, second life application, but not on the battery passport. But I take advantage to say that we are in another project for Internet called Free4Lip that works on what happens at the end of the battery with the materials, and there we work with this battery passport, but not in MARBEL.
So we have to use. Okay, thanks.
When I'm looking at the battery passport in Helios, we are doing digital twin, LCA, LCC, and all these things, but we're not putting everything together in a passport. So it's probably just one step short of that.
For the ALBATROSS, the data coming from the BMS will be collected in the cloud system, but there is no specific passport creation in the scope of the ALBATROSS project, but the data will be used in the KBE tools for the life cycle assessment, but there is no specific applications for the battery passport in the scope of the ALBATROSS, but the data will be collected in the cloud system and analyzed in each single data arrive to the cloud system from the BMS.
Okay, thank you. Any other questions? Yes, thank you.
Hello. Does any of the groups have made a analysis of the cost of these cloud solutions in an industrial, let's say, no, in a mass production situation?
Any answer on that?
No. The answer from Liberty part at least is clear. No, we didn't.
Yeah, in Helios, we kind of scratched the surface a little bit in this. I mean, of course, we're kind of in the middle of the project, but we did look at requirements and needs for managing all the data, depending on sampling frequency, upload rates, all these things, at least as an extrapolation from the case that we have. But it's preliminary, so these things are going to be updated as we move along. We haven't looked at costs yet. We have, of course, the cost for one time off, right? Potentially extending from there. I mean, we haven't finished it, but we are considering the impact on a large scale, of course.
Yeah, in our side, in our project, we didn't also plan this, but I think it's a good idea not only to assess the cost of using cloud services that enhance your capacities to make calculations, complex calculations in a VMS, etc., but also cost and environmental impact, for instance, because you are externalizing some part of the calculations, some part of the materials, the energy needed for that. And maybe it's, you gave me an idea once we make the assessments of reductions, well, of life cycle cost, life cycle assessment, that I will ask the colleagues leading this if we should consider this. Maybe it's worth. No. Thank you.
So maybe I can add one thing more about the Helios, right? So so we looked at all the data requirements to update digital twins in real time and all that. I don't remember exactly the numbers, but I do remember one of the comments were, really? That's it? So it doesn't seem to be a constraint, actually.
Okay, thank you. Any further questions? Okay, because I also have prepared a paper full of questions, but since the question amount of the audience was that big, I had to clear. Okay.
Since we have to use all the time, I have one. I have one question. From the opening session, I got somewhere in my ears synergies, systematic or studies at system level, affordability, and so on. And then yesterday we got a lot of advanced technology on batteries, very interesting solutions. This morning, very interesting solution on lightweighting. And my question is, how all this will help us to, how it's connected all together? Do you have any connection with the batteries project and with the lightweighting project to take the best solution found there, applied on packs, and vice versa?
You mean the synergies between lightweighting material projects?
Even other projects.
Yeah. For instance, in our case, this methodology of eco-design approach, we are also using one of the projects that was presented in the morning, Fatigue for Light, for aluminium structural parts. And yeah, there is, we like to work in synergy with other projects, for especially what's the role in EURECAT in MARBEL, that it's more defined on the lightweight materials, in terms of aluminium, for instance, in high pressure die casting, in this case MARBEL extrusion. But we try to take advantage from results from one project to other and try to build up a portfolio of a strategy, on certain aspect of the technology. and work it with different technology, different applications. Yeah.
Yeah, so I think this is an important question, right? And probably that's why we have this kind of events, and that's why we have the next round of calls, right? So I think, at least in my mind, there seem to be a number of activities, right? Also, it's up to the industry to come and pick and choose. So of course, I mean, we're listing a range of options. The industry could select what they like. I don't think it's up to these projects, but of course the question is relevant. How do we scale up at the industry level? I think the way when I look at everything that we have on the table, right? I think we have quite a number of options, right? The question is, is anybody going to pick it up? And that's there's still an open question. It's up to the industry basically to come and select what they need, right? Our industrial partners are actually using some of the results internally, right, and developing their R&D efforts and things like that. But of course, this is not something that's public, right? So you're not seeing this, of course, we're thinking that, you know, probably nothing happens. But, you know, so I think it's an important question that, you know, we're just going to have to ask ourselves as, I don't know, researchers, political bodies, you know, all these things, you know, how do we ramp it up?
And also we are also collaborating in the LEVIS project, and we are currently manufacturing the battery tray system for fully extruded aluminum solutions, like what Eduard mentioned before. And we are following the lightweight solutions and implementation of the both composite material and hybrid usage aspects for and the feasibility for the industrial scale. Is it applicable or not? We are at the same time following the current progresses as well.
So maybe regarding the links we have with other projects, it's not always an easy task. Well, actually, one of the big links we have in this case is the Collabat cluster, in which we are, I would say it's quite active between projects, so that makes to take a little bit more benefit from other projects, since we are facing similar challenges. And also another strong link we have is that the vehicle used in Liberty comes from another European project, which is 1,000 km plus. They are developing a high voltage system, the whole drivetrain, and that's the vehicle that is going to be used for validation and so on. So there is some level of interconnection, but it's not always easy. So we have to remember that we have industrial partners, and it's not that simple, but there is some kind.
Okay, thank you. Is there one last question? If not, I will hand over to Ma.
Okay, so let's wrap up the session. Just before leaving, to remind you that the next session is at Room Einstein at 4:30, and it's about stakeholders' experiences of successful interactions, to connect with the last question, and integration of R&I activities. Also, in the meantime, you can visit the RTR exhibition and the EC stand and meet the coordinators of New Horizon Europe projects. So thank you very much for attending this session. And I think it was a very successful session for all of us, and we learned a lot of things.